folks, Ms. Gosling here. In this video, you are going to be learning about equilibrium. By the end of the video, you'll be able to determine the value of missing forces in equilibrium problems. So let's go ahead and get started by defining what equilibrium even means. So in this situation, equilibrium is when the sum of forces, often written as the sum of the forces, or F net, is equal to 0. So, for example, if you are sitting on your chair, not moving right now, the sum of forces acting on you is 0 because you are not moving. And that gets me to the second part, the second thing that's important to know, and that's how to recognize equilibrium. And the way we can actually recognize that is by thinking back to Newton's first law. So we know that when no net forces act on an object, so when the net force acting on an object is 0, it is going to be in an inertial state. That is, its velocity will be constant. So we know if the sum of the forces on an object is 0, the velocity is constant. So you might see something like a car is moving at a constant speed or at a constant rate or at a constant velocity. And so that's one way to tell that we are in an equilibrium situation. You could also say that your v is 0. Of course, that's a specific case of being constant, but if you're at rest, then the sum of forces acting on you is 0. Or that our acceleration is 0. And all three of these things are telling me the same thing, that my object is in equilibrium. So let's go ahead and use that to solve some problems. Before I do that, though, I do want to talk about how we solve the problems, because there really is an approach. So first of all, you're going to start by drawing a free body diagram. Then you'll want to determine the magnitude of known forces and determine your unknown force. Let me go ahead and take a moment to highlight too. So draw a free body diagram. You're going to figure out the magnitude of your known forces and unknown forces. And when you do that, you want to split all forces into x and y components. You'll set your sum of forces in the x direction and sum of forces in the y direction both equal to 0, and then solve. So now let's do a nice, easy example. A box of mass 10 kilograms is pulled along a horizontal surface at a constant rate. If the frictional force acting on the box is 10 newtons to the left, or 7 newtons to the left, find the value of the normal force and applied force on the box. So I'm going to start by drawing a picture of what's going on. So here is my box, and it's being pulled across a horizontal surface at a constant rate. So I know that v equals constant. Therefore, acceleration, or F net, is equal to 0. And that means that the total force in the x direction and the y direction are both going to be equal to 0. So let's start by following step 1 and drawing a free body diagram. So my box has mass, therefore gravity is going to act on it. So I'm going to start by drawing my vector for the force of gravity. And in the direct opposite direction of gravity, I have my normal force acting up. Then I know that my frictional force is pulling the box to the left, and another force, my applied force, is going to be pulling the box to the right. So the next step is to figure out the magnitudes of my known forces. And that's going to be the force of gravity and the force of friction. So I know that my gravitational force is my weight, or my mass times the gravitational constant, or 10 times negative 9.8. So my gravitational force is going to be negative 9.8 newtons. I can also find my frictional force. So my frictional force is actually given in my problem, and that is going to be 7 newtons to the left, which I'm going to define as negative 7 newtons. And when I do that, I'm also going to go ahead and draw my x, y axis, showing me my positive and negative x and y directions. Okay, so I've gotten to my second step, and I know that my unknown forces are my normal force and my applied force. Now I can skip my third step because I don't need to split my forces up into x and y components since they're already perpendicular to one another. So what I will set then is that the sum of forces in the y direction is equal to 0, and the sum of forces in the x direction is equal to 0. So in the y direction, I have gravity and the normal force, and when added together, they'll be equal to 0. I know that my gravitational force is negative 98 newtons, and you can see here I miswrote it here. I got so used to writing my 9.8 that I forgot to get rid of it. So 98 plus my normal force, and that together is going to equal 0, telling me that my normal force is 98 newtons. And there you go. I have solved for my normal force. Now I can do the same in the x direction to solve for my applied force. So in the x direction, I have a frictional force and I have an applied force. And I know that when added together, they'll be equal to 0 since we are moving at a constant rate and are therefore in equilibrium. So my frictional force is negative 7, and my applied force is my unknown. And when added together, they equal 0. And that gives me that my applied force is equal to 7 newtons. And there you go, guys. That is one nice, simple problem that we can solve. Now let's try something a little bit more complex. So here I have a 1 Newton donut being held up by 2 strings, each at a 45-degree angle to the ceiling. What is the tension force in each string? So let's go ahead and draw my free body diagram for this problem. So here's my donut being represented as it should be, as a dot. I know that the force of gravity is acting down on my donut. And I know that each of my tension forces is acting up. And I have not done a great job here, guys, of drawing my vectors proportional to each other, because I know that the gravitational force is going to be bigger than my 2 tension forces, since those 2 added together are going to have to equal my gravitational force. So let me go ahead and fix that here. Finally, I know that both of my tension forces are at a 45-degree angle, which is going to be very, very important when I'm splitting my forces into x and y components. So I know that the force of gravity is equal to 1 Newton. And I have 2 forces of tension, so I'm going to call it Ft1 is equal to Ft2. And they're equal to, I'm going to just call that Ft, which is something. And this is just a way for me to simplify everything since I know that they're equal to each other. So now let's go ahead and figure out the next thing. And that is going to be separating my tension forces into x and y components. And to do that, I want to zoom in on one of my vectors. So here is my tension force, and it is at a 45-degree angle with the horizontal. So I can draw my force of tension in the x direction, and I can draw a vector for my force of tension in the y direction. And if I had drawn these a little more neatly, I would recognize that this is a triangle, and is in fact a right triangle. So what that means is I can use my sines and cosines, my SOHCAHTOA, to break my force of tension down into its x and y components. So I'm going to skip how we do that, and I'm just going to go ahead and tell you what the answers are. If you want to go through this on your own, you are welcome to. But what I will get is that my force of tension in the y direction is equal to the force of tension times the sine of 45. And the force of tension in the x direction is equal to the force of tension times the cosine of 45. So now I'm ready to sum all my forces in the x and the y directions. Before I do that though, there's one thing I forgot, and that is that my force of gravity is down. So that means it's negative. That's a really important thing that we need to, you guys always want to make sure that you put in. You can see I forgot that here, and that's going to be important for you to remember. Okay, so let's go ahead and look at the y direction. So I know that in the y direction, I have the force of gravity acting on my object, and I have two tension forces acting on my object, but just the y components of them. And those are going to be equal to a total force of 0 newtons. So then what I can say is that the gravitational force on my object plus 2 times the force of tension in the y direction is equal to 0. And when I solve for that, I got the force of tension in the y direction is equal to 0.5 newtons, which I can then plug back into my equation. So remember, I've only found the y component of my tension force, and I want the total tension force. So I know that Fty is equal to the force of tension times the sine of 45, or 0.5 is equal to the force of tension times the sine of 45. So the force of tension is equal to 0.5 over sine of 45. And there you go. Now, when you're doing this on your own, you'll probably want to stick this in your calculator and get an actual number. I like to leave it like this because I don't feel like getting my calculator out. Okay, so let's go ahead and talk takeaways then. So the first thing is that an object that is moving at a constant rate is in equilibrium and has a net force of 0 newtons acting on it. And the first thing that you need to be able to do with these problems is recognize when you're in equilibrium. Once you recognize that you're in equilibrium, you can use that equilibrium condition to determine the magnitude of individual forces acting on an object. So there you have it, folks. You have now learned about equilibrium forces. Go ahead and try solving some problems on your own. Best of luck and happy solving.